Hello students, good morning. 12th standard chemistry, unit 2, P block elements. Dear students, in this lesson we are discussing the topic general trends in properties of P block elements. And under this heading, we have completed many things. We have completed electronic configuration, oxidation state, metallic nature, ionization enthalpy, electronegativity, and anomalous property of the first element. Up to this we have completed, and today in this video we are going to see what is called as inert pair effect. It is very important concept that we are going to see in this video. Okay, let us move on to the video. We can discuss what is called as inert pair effect. Okay, dear students, inert pair effect. Okay, first we must know the meaning of the terms inert and pair. Okay, the word inert means unreactive. Its reactiveness will be very low. Okay, then pair means we know that is true. A couple of anything can be called as pair. Okay, so inert pair. Here the term pair represent electrons, a pair of electrons, inertness of a pair of electrons, that is called as inert pair effect. And this effect can be shown only by P block elements. It can be shown by any other blocks of elements. It cannot be shown by S block, it cannot be shown by D block, also it cannot be shown by F block elements. Only the elements of P block can show this special effect called inert pair effect. Is it clear, students? What is inert pair effect? The inertness of a pair of electrons present in S orbital. Okay, before that we must know the electronic configuration of P block elements that we have seen in the previous video itself. What is the general electronic configuration of P block elements? Yes, it is Ns2 Np126, which means permanently there are 2 electrons present in the s orbital and the number of electrons in the p orbital will vary according to the element. Okay, so there are 2 electrons permanently present in s orbital of the P block elements. Okay, and this 2 electrons present in the s orbital shows inertness towards reactivity, and so this effect is called as inert pair effect. Okay, mama. Okay, look at the next point. What is given? It is a special character of P block elements that I told you previous itself. Okay, it can be shown only by the elements of P block. The other blocks of elements will not show the inert pair effect. Okay, mama. Okay, now let us see the definition of inert pair effect. Okay, let me read. This is inert pair effect. What is given? In heavier post transition metals. Okay, students, what is given? In heavier post transition metals. So here we need to know what is called as post transition metal. We know the construction of the periodic table, isn't it? Yes, it has 4 different blocks. This side S block will be there, then here D block will be there, and here it is P block. Okay, so which is the place of transition element? This is the place of transition element. So post transition means the elements present next to the transition element, they are called as post transition elements. Are you able to understand what is post transition element? The element present next to the transition elements are called as post transition elements. Okay, okay. So in heavier post transition elements, the outer s electrons, that is the electrons present in the s orbital, so these 2 electrons, they have a tendency to remain inert, which means they are unreactive. They are unreactive and show reluctance to take part in chemical bonding, and this effect is called as inert pair effect. So what is inert pair effect? It can be shown only by P block elements. Also mainly it is shown only by heavier post transition elements. the inertness or unreactiveness of the pair of electrons present in the s orbital. That is called as inert pair effect. Are you clear what is inert pair effect? Let me read one more time the definition of inert pair effect. In heavier post-transition metals, the outer s electrons have tendency to remain inert and shows a reluctance to take part in bonding, and it is known as inert pair effect. Okay, now look at this question. It's very important. Thallium plus 1 is more stable than thallium plus 3. Why? Okay, dear students, first we must know thallium belongs to which family. Okay, thallium belongs to boron, aluminium, gallium, indium and thallium. So thallium belongs to boron family. What is the electronic configuration of boron family? It is ns2np1. ns2 np1. Here there are two possibilities. This thallium can lose the two electrons of this s orbital and one electron of this p orbital, and it can be converted into thallium plus 3. It is one possibility. Another possibility is it can lose only the electrons of this p orbital and it can become thallium plus 1. So there are two possibilities, but out of these two possibilities, which is more stable? This thallium plus 1 is more stable. Why? The reason is inert pair effect. We have already seen the electrons present in the s orbital remain inert, which means it cannot be lost easily. So the thallium atom has a tendency of losing electrons only from this p orbital. So by losing one electron in the p orbital, it will become thallium plus 1. So because of inert pair effect, which is more stable, thallium plus 1 is more stable. That is given here. Out of thallium plus 3 and thallium plus 1, which is more stable? Thallium plus 1 is more stable. What is the reason? It is due to inert pair effect. Is it clear, students? So with this, inert pair effect is over. Okay, ma? Go through the video and have a clear understanding of inert pair effect. Thank you.